You know that high-pitched whine you hear on a summer night? We all know that sound. But the tiny creature making it is so much more than just a pest. It's a master hunter. So today, we're going to go on a mission, a briefing really, to uncover the incredible science behind how a mosquito finds you, and maybe more importantly, how it bites you.
Okay, let's just dive right in by completely reframing this whole thing. I know your first instinct is to just swat it, but for a second, think of the mosquito as this highly evolved specialist, equipped with some of the most sophisticated biological tools in the entire animal kingdom. Its goal? To complete a complex, multi-stage mission. I mean, it's a super common experience, right? You're in a pitch-black room, and somehow this little insect homes in on you like a guided missile. How in the world does it do that? Well, that brings us to the very first phase of its mission.
To pull off its blood heist, the mosquito first has to find its target. And this isn't random at all. It's a really systematic process that uses a combination of long-range and short-range sensors to zero in on a meal. Let's start with this number, 20 meters. That's over 65 feet away. From that incredible distance, a mosquito can pick up its very first clue that you are nearby. So the question is, what is it sensing from that far away? That's right, your breath. Every single time you exhale, you release a plume of carbon dioxide, and mosquitoes have these ridiculously sensitive receptors for it. That CO2 trail acts like a giant, invisible beacon in the air, guiding them from way out there right into your general area.
Okay, so once your breath has lured them in close, a whole new set of sensors kicks in. Now they can smell this complex cocktail of chemicals that you're just constantly giving off. We're talking your unique body odor, chemicals in your sweat, and even byproducts from things you've consumed, like alcohol. So yeah, having that beer on the patio can literally make you a brighter target on their radar.
So, if they're sensing all this stuff from our bodies, why does it always seem like they have a special preference for buzzing around our heads or attacking our ankles? It's not just in your head, it's actually part of their strategy.
And here's the simple reason. Your face is basically ground zero for that big CO2 and humidity beacon that they followed in the first place. And at the other end of your body, your feet produce this really unique and powerful blend of odors that, to a mosquito, are just irresistible. So the takeaway here? They aren't aiming randomly. They're going where the signals are the absolute strongest.
All right, they've found you, they've landed. Now, the infiltration begins. Once the mosquito is in position, it deploys its equipment. And this is where we have to correct a huge misconception. That thing it bites you with, it is not a straw. It is something way, way more complex. What we see is called a proboscis. But that part you can see, that's just a protective sheath. Tucked neatly inside is a microscopic toolkit of 6 separate, highly specialized needles. And each one has a very specific job to do. This isn't just a poke, it's a full-on infiltration.
This is just incredible. Seriously. First, that outer sheath pulls back like a sleeve. Then, 2 needles with tiny serrated tips, like little saws, get to work cutting an opening in your skin. 2 more needles act like clamps, holding the tissue open. A 5th needle starts pumping in saliva that's full of anticoagulants. This is the stuff that makes you itch later, but its real job is to stop your blood from clotting up. And only then, once all that is done, does the 6th and final needle, the feeding tube, actually start drawing your blood. So the tools are in place, the incision is made. But the mission is not over, not by a long shot. In fact, one of the most critical parts is just getting started, and it's happening completely out of sight, right underneath your skin.
See, the mosquito can't just drink from anywhere. The whole point is to find a capillary, one of those tiny blood vessels. So that central feeding tube is actually flexible, and it bends and probes around under your skin, actively hunting for a vessel to tap into. And here's the cool part. You can actually see the evidence of that search later on. That one big itchy bump, that's the spot where the mosquito finally hit the jackpot and got a full meal. But have you ever noticed those tiny little red dots around the main bite? Those are the failed attempts, the little puncture marks from where the mosquito probed, missed, pulled out, and had to try again. All right, now that we've seen the entire mission, from target acquisition all the way to extraction, let's finish our debrief by tackling a really common myth about how to stop a mosquito mid-bite. You've probably heard this one before, right? That if you see a mosquito biting you, you should flex your muscle really hard to trap its needle so it gets stuck and pops. It's a pretty satisfying thought, but the science says it's just a myth.
Remember, that whole proboscis is only about 2 millimeters long. It's only ever working in the very top layers of your skin, looking for a capillary. It simply can't reach deep enough to get trapped by a muscle. So we've covered a lot here, from long-range CO2 tracking to a 6-part surgical toolkit and a hunt for blood happening under your skin. What does this all really mean when you put it all together?
It means that the next time you feel that all too familiar itch, you can appreciate the sheer, mind-boggling complexity of what just happened. You weren't just bitten by some dumb pest. You were the successful target of a microscopic marvel of engineering on a mission for survival.